Have you ever wondered where the silver we see in jewelry, coins, or electronic devices comes from? This metal not only stands out for its characteristic shine, it's also the best conductor and most reflective of all known elements. Every year, thousands of tons are extracted from the depths of the earth, traveling a long way from hidden veins in the rock to become gleaming ingots of extremely high value. This journey begins at the very heart of the Earth. In the Earth's mantle, thousands of meters below the surface, streams of magma laden with minerals rise slowly. This magma, a product of volcanic and geothermal activity, carries tiny particles of silver that accumulate at certain strategic points in the crust. When the magma cools and solidifies, the minerals crystallize, sometimes forming valuable veins. Over millions of years, groundwater rich in chemical compounds circulated through fractures in the rock, depositing silver there along with other elements. The result was hydrothermal veins, true metallic threads embedded in the rock, which became the basis for silver mining. About 170 million years ago, the collision of tectonic plates raised the Andes mountain range, which, in addition to being one of the most impressive mountain ranges on the planet, became one of the richest areas in minerals. It was in these mountains that the legendary Cerro Rico de Potosí was discovered, a mountain that seemed to be made of silver. In the 16th century, when the Spanish conquistadors arrived in the region, they found veins up to 3 meters thick, a wealth so extraordinary that it turned Potosí into the world's mining epicenter. The importance of this discovery was enormous. For 3 centuries, Potosí supplied around 80% of the world's silver, giving rise to a true economic revolution. The magnitude was such that chroniclers of the time claim that with all the silver extracted, a bridge could have been built from Madrid to the Bolivian mountain itself. There, in 1553, a Spanish merchant named Bartolomé de Medina introduced an innovative method, patio beneficiation. This technique, which used mercury to separate silver from the rock, multiplied production and turned Potosí into an unparalleled industrial complex, where around 220 tons of silver were produced annually. The extracted silver was transformed into coins known as pesos of 8, which circulated on all continents and are considered the first global currency in history. They were so valuable and recognized that even the United States accepted them as legal tender until 1857. It is estimated that more than 2.5 million coins were minted each year, and that in total, Spanish fleets transported more than 50,000 tons of silver from the Americas to Europe and Asia. This massive flow not only fueled international trade, but also shaped the destiny of entire continents. Today, centuries after that colonial boom, silver remains a key resource. Mexico leads the world in production, contributing nearly 20% of the global supply. The Proaño mine in Zacatecas is located within its territory, which has become one of the most important deposits on the planet. With over 450 years of operation, this mine has produced more than 30,000 tons of silver throughout its history and continues to generate more than 1 million kilos annually. The modern extraction process begins long before a single rock is removed. It all starts with geological exploration. Experts use advanced tools such as radon guns, geochemical studies, and 3-dimensional mapping systems to locate promising deposits. These tests analyze up to 40 different elements, and although silver does not appear as a shiny metal, but rather as a dark grey mineral, the studies make it possible to precisely identify where the richest veins are located. Once the area is located, excavation begins. The miners descend more than 400 meters underground, where the heat and humidity can cause temperatures to exceed 45 degrees Celsius, making each workday an extreme challenge. The scale of the operations is impressive. More than 600 kilometers of tunnels have been excavated over 4 centuries, and each month, around 3,000 additional meters are opened with the help of enormous rotary cutting machines that tear through the rock with constant power. Before the ore can be extracted, the ground is prepared with explosives. Geologists use precision lasers to mark the exact points where holes approximately 115 millimeters in diameter must be drilled. Dynamite charges are inserted into these holes, which, when detonated, release thousands of tons of rock without causing collapses. Precision is vital. A miscalculation can mean a catastrophic collapse. Every day, nearly 7,000 tons of material are extracted and transported by underground trains and hoppers to the surface, where geologists and technicians analyze the samples and blend them to maintain a uniform silver concentration. Once the ore reaches the processing plant, one of the most important phases of the entire process begins: the mechanical preparation of the rock. This step aims to release the silver contained within the fragments and prepare it for subsequent chemical treatments. The material's first contact with machinery occurs in the primary crushers, large pieces of equipment powered by reinforced steel jaws, capable of breaking rocks weighing several kilograms in a matter of seconds. The noise is deafening, and the force with which the rocks are compressed against the metal plates allows them to be reduced to much more manageable fragments. From there, the material advances on conveyor belts to a second crushing process that further refines the particle size, ensuring that no stone is too large for the next process. These fragments then enter ball mills, true industrial giants that dominate the plant landscape. These mills are metal cylinders several meters in diameter that rotate constantly. Inside, they contain solid steel balls, some of them the size of baseballs, which as they spin fall and forcefully strike the rock fragments. The friction and repeated impact cause the material to become progressively pulverized. The process is continuous and controlled. The rotation of the mills, the speed, and the number of steel balls are carefully regulated to ensure the mineral reaches the appropriate particle size. After several hours, what began as solid rock becomes an extremely fine powder known as pulp. This pulp, composed of rock particles mixed with water, is the perfect starting point for the next stage of flotation, where the separation of silver from other impurities begins. In this way, the passage through crushers and mills not only reduces the size of the mineral, but also opens the door to the true chemical transformation that will allow the silver to be concentrated and transported to its final destination, to become highly pure ingots. The pulp then enters the flotation tanks, where it is mixed with water and chemicals that cause the silver to adhere to air bubbles and float to the surface. The waste sinks, allowing the valuable part of the material to be separated. Thanks to this process, the silver concentration increases up to 30 times that of the original rock. After 72 hours of resting and filtering, a precipitate composed of 50% silver and 50% impurities is obtained. This precipitate is dried in gas furnaces and then smelted. At this point, one of the most spectacular transformations occurs. The silver and waste separate due to their density differences, and the heavier metal settles to the bottom of the molds. In just 5 minutes, the molten silver solidifies, forming an ingot. This is the moment when all the mining effort materializes into a lustrous bar ready to be refined. The ingots are transported to the Medmex refinery, the largest in Latin America and the fourth largest in the world of its kind. There, the goal is to bring the metal's purity to near absolute levels. The ingots are melted again at temperatures exceeding 800 degrees Celsius, allowing for the separation of other metals such as lead, which oxidize and are eliminated from the metal flow. The initial result is 99% pure silver. Although the smelting process achieves 99% purity in silver, a small percentage of other associated metals always remains. That last 1% is usually composed primarily of gold, and a very precise refining method is used to separate it: electrolysis. This procedure allows the metal's purity to be brought to near absolute levels, and is essential for silver to be certified and traded on international markets. The technique involves immersing metal plates in a silver nitrate solution. One plate acts as the cathode, negatively charged, and the other as the anode, positively charged. When an electric current is applied through this solution, a controlled phenomenon occurs. Silver atoms dissolve from the anode and travel through the solution to deposit on the cathode, where a layer of extremely pure silver accumulates. Meanwhile, heavier elements, such as gold, do not react in the same way and remain on the positive plate, facilitating their separation. This process produces silver with a purity level of 99.9%, which in industrial terms is considered practically perfect. The metal refined using this method meets international quality standards and becomes a product ready to enter the global market in the form of certified ingots. Each ingot not only represents the culmination of a complex extraction and refining cycle, but is also a highly valued piece that can fetch a price close to $1,000 per unit, although its exact price depends on fluctuations in the international precious metals market. In this way, electrolysis ensures that silver's journey from its origin in the depths of the earth to its arrival at international markets ends with a reliable, pure and essential product for modern industry. Behind every silver ingot lies a monumental chain of work involving different specialists, technologies and trades that together make it possible to transform an opaque mineral laced with impurities into a lustrous, highly pure bar. It all begins with the work of the miners, who descend every day into deep, stifling galleries. In these narrow tunnels, where the heat can exceed 40 degrees and the humidity makes breathing difficult, they make their way through rocks that have remained intact for millions of years. Their physical effort and courage are the first step in a process that demands perseverance and endurance. From there, the task passes to the geologists, whose precision is key. They, with the help of modern equipment such as lasers and special sensors, accurately determine the location of the most promising silver veins. Their calculations allow them to drill at the right point and extract the material without waste, optimizing the work of the entire mine. Then the power of the machinery comes into play. Enormous equipment with cutting heads, drills and controlled explosives break up and release tons of rock, which are transported to the surface in trains and hoppers. This seemingly worthless mass of stone contains the resource that will soon be separated with the help of chemistry. In laboratories and processing plants, chemists use reagents, flotation and filtration to separate the silver from impurities. This work requires delicacy and precision, as any error can affect the quality of the concentrate. From there, the material emerges, which after passing through melting furnaces, takes the form of an ingot. Finally, metallurgists complete the cycle with precise smelting and refining techniques. They ensure that the metal reaches a near absolute level of purity, eliminating all traces of other elements. The result is a solid, gleaming ingot that not only symbolizes wealth, but also humanity's progress in science, technology, and industry. Silver, which was once formed in the depths of the planet thanks to the force of magma, is now transformed into an essential material for our daily lives. It is used in cell phones, computers, solar panels, jewelry, medicine, and even space projects. From the Earth's interior to the most modern applications, silver remains, centuries after its discovery, one of the most fascinating and influential metals in all of human history.